Hello, this is my attempt at Lemiscular rays in Godot. So as you can see, this is an example project where we have a sun which casts rays, and the mountains essentially block those rays. So what we're going to do is we're going to start off with a project that most people probably have. It's just essentially a parallax background with some layers in it, acting as the background. You can get these in the description. I made these, but you're free to use them. And so here's pretty much just our project settings. You can see it has 1280 by 720. I'm turning off resizable. So I think this website does a pretty good job explaining exactly how to make Lemiscular rays, and this is what we're going to follow when we're making this tutorial. You can read about it, and I'll put a link to it, but essentially what it says is we have a light source in the very far background, and our mountains in this case would be essentially a black layer on top of this light, and the very end we're going to take this light, which is rendered in a separate viewport, and just put it over the mountains in an additive canvas layer. If that sounds confusing, don't worry about it. What we're going to do is we're going to take a viewport, which is essentially going to be where we render all this light and the light masks. We're going to set it to the size of our screen, which is 1280 by 720. We're going to create a world and make it have a transparent background. Make sure you enable unworld. And after that, we're going to v-flip it because viewports naturally flip vertically. And after all of that, what we're going to do is we're going to copy our parallax background, which is the colors for our mountains, which is our far backgrounds. Now what we're going to do is we're going to modulate the mountain layers black, because this is going to be our mask that we apply on top of our light. And so we just go to the modulate property over the 3 layers, and we're just going to put them to the color black. Now we do need to have a camera in order for us to be able to move alongside the viewport. We're going to add a script to this later that essentially copies our player's camera and sets this camera inside this viewport to the same position that the player is in, because our viewport is rendered separately from our main viewport. So now we're going to add a script to the main scene, which is where we're going to do this. You can put this wherever you would want. I just put it in a specific scripts folder. And we're just going to create a process function, which just happens every single frame. Now we're going to set our viewport camera's 2D position equal to our player's camera's 2D position. Now my player has just a camera with the name camera. Yours might have camera 2D. Make sure to also set the offset equal to the same value, and make sure the position is a global position, because our camera might have a position of 0, 0, and it might not reflect on the player's position too. Now, what we're going to do is we're going to add a sprite to our parallax background. Now this is the sprite that renders on top of everything else, which means it has to go to the very bottom of the parallax background, and this is what's going to render the light at the very end. But for right now, it's just going to render exactly what's in our parallax background, which right now is just a black mask. So now in Already, we're just going to set our viewport's texture to this new sprite that we created. You don't have to call this in Ready, you don't have to set it once. Godot will naturally update it every single frame. That's what the get textures does. If you run this, it should be a perfectly black mask of our background, and you can turn the visibility of our sprite on and off just to make sure it is perfectly on top. And you can see it seems to be perfectly on top here. You can walk around, make sure our offset and our position are perfectly right. If it doesn't move, you probably do not set the camera to update its position. So going back to the website we mentioned before, you can see this black thing in this image is essentially what our viewport's parallax background is right now, right? It's just a black mask. So to create these Lemiscular rays, we need to actually have a light source in the far background. So we're going to go back to Godot, and to create this far background light source, we're just going to have pretty much like a yellowish sky background. And this is essentially going to be our light that we will later put a shader on top of that will create the rays on top of the black parts. And we're just going to set our size to be the screen size. And so we're going to move the back light back to where it should be, which is at the very top of the parallax background in the viewport. And we're going to run the scene, and it should be a perfectly white background with a black mask, or black mountain mask on top of it. You can turn on and off the sprite just to make sure that it is still perfectly on top. So now what we're going to do is we're just going to create like a sun, and for this we're just going to put a sprite, and I already have a sun image loaded up in our assets folder. I'm just going to copy that over to our texture. And what we're going to do now is we're just going to set our position. What I mean is we're going to put our modulate to a nice sun color, which is a nice yellow. And I'm going to put it to 200 or just some number. Because 0, 0 would be the very top left of our screen, which would not really work. That's not really where the sun would normally be. I want to keep it about where the horizon, the skyline of the mountains are. You can see I don't really like the position. It might take some finagling of some numbers to get the exact right position of where you want it to be, because it depends on your game. I like that position, so we're going to roll with that. Now, we want to create the actual Lemiscular rays. As shown in back over here on the website that I mentioned before, you can see those rays sort of come out away from the sun, which is what we're going to... So in that website, they had some shader code that they used to create the Lemiscular rays. I just converted it into Godot shader code and took some principles from that and added some uniforms to work with our project here that you can also use, that I will link in the description. There are a bunch of uniforms that we're going to change, some settings that you can do. You get to play with all of these numbers, beautiful numbers, in our final scene. You can see the decay changes how far the rays decay, how fast they decay, the weight, the amount of rays, the exposure of the whole shader, and whether it will use the screen coordinates instead of the actual texture coordinates. And that's what we're going to do when we put this in our parallax background. Now, in our viewport's parallax background, at the very bottom, we want to add a sprite. And this sprite will be our mask, essentially, or shader, not our mask. And we're just going to put a 64 by 64 texture in it. You could just put a 1920 by 10, or sorry, a 1280 by 720, or just whatever screen resolution you want. But since we have just a 64 by 64, we're going to do some scaling math just to make sure it covers the whole screen. You don't have to do this if you just have a 1280 by 720 texture. But I'm going to run that, and I'm going to make sure it's centered, or else that's what's going to happen. And you can see it covers the whole screen, which is pretty cool. Now what we're going to do is we're going to add a new shader material. And in this new shader material, we're just going to copy over the shader that we mentioned before. So now that we have the shader ready, we want to go back to our scatter sprite, and we want to turn on use screen under the shader parameters, because we want to use the screen's sprite, and we don't want to use the specific texture sprite. Now if we run this, you can see our arrays should work. They come from the light screen positions value under shader parameters. You can change that vector too. Now the obvious question is, how can we get this to render on top of the colored parallax background, the actual parallax background? And for that I have to go back to our sprite that we render, and we want to add a canvas item, and we want to set it to add. What this will do is this will set all of the black parts of our mask to be transparent. And now, as you can see, all the black parts are in fact transparent, and they are rendering the mountains that we have in our basic parallax background. But obviously the rays are a bit too strong, so what we're going to do is we're going to go back to our color correct, which remember is our background sky, and we're just going to make it a bit more yellow and make it more transparent. And now you can see that the rays are significantly lighter and easier to look on the eyes. And all it comes down to now is pretty much just setting values, changing modulations of sprites and going back to our scatter shader and changing parameter values on those to make it better suit your purposes. As you can see, we're changing the light position vector to make it right on top of the sun. And now the rays emanate sort of from the sun. Like I said, it does take a bit more fine-tuning. You can see going down by increasing the Y value, and this does look much closer to the sun. But what if you want your rays to be a bit longer? Well, you can change the density, you can change the decay, you can make the decay a bit less. And you can see me doing that, and I think the final result just comes down to what does your game need, right? The values are very dependent upon your specific game, how big your sprites are and all. And it really just depends on that. I think the final value that I came to works pretty well in my situation, but it really does depend. This adventure was made possible by the game that we've been working on, Dungeon Rogues. Please look at the link in our description and join our Discord server to find out more. We're still working on some demos and some possible alphas soon.